Dear friends, in my previous lecture, we have discussed about the cellular structure and cell design. In continuation, today we will discuss about the frequency reuse in these cells and their importance. Here, this is a cell cluster which has 7 cells, and all the 7 cells have the different frequencies, and they have the group of channel, and each channel has the bandwidth of 200 kilohertz. In this cell cluster, each cell has its own transmitter, that is called the BS. This is the BS 1, and they have their own antennas. In the similar way, this is the another BS 2, which has its own antennas. In the similar way, all the 7 cells starting from 1, 2, 3, 4, 5, 6 and 7, they have their own base stations, and each cell has its own group of channels, and these channels are normally 8 to 10. Some channels are for voice control and some channels are for the control purpose. So, this is one group, but a city which has a large number of the base stations. The group may be a different type. See here, this is the cell structure which has number of clusters. For example, this is one cluster, this is another cluster, this is the another cluster, this is the another cluster. In this way, there are hundreds of clusters. If there are hundreds of clusters, there are hundreds of base stations, and we have already explained that each base station has 6 to 8 channels. It means the number of channels goes in thousands. So, how will manage these things? There may be some limitations. The TRAI, Telecom Regulatory Authority of India, allocate you a fixed spectrum. This spectrum may be 5 megahertz, 10 megahertz and maximum 25 megahertz. If the each channel which has 200 kilohertz bandwidth and there are thousands channels, the spectrum will go in gigahertz, which is beyond the control of TRAI. Then you have to find out some solution. Another limitation is the transmitting, switching and control resources. If each cell has its own frequency, own channels, then how many types of transmitter you will need, because each has its own frequency. The third problem is the compatibility among the different equipment manufacturer and their maintenance problem. If the 1000 types of equipments are available, their compatibility with each other and their maintenance problem. And the third and the fourth is each cell requires more voice and control channels. So, we have to find out some way to overcome these problems. If there is solution for it, Yes, we have some solution also. And what is that solution? Frequency reuse or frequency planning. You have to make the certain arrangement such that certain band of frequencies can be reused after a certain distance, and this is called the frequency reuse. The same frequency band or channel used in a cell can be reused in another cell as long as they are far apart. So, you can reuse them seeing a fixed distance. What is the condition? The signal extent do not interfere with each other. This in turn enhance the available bandwidth of each cell. If you have planned the frequency, you can increase the bandwidth also. So, let us see the cell cluster. A cell cluster of several cells into overlapping area is here, no overlapping area. In the cell of cluster, there is no overlapping area. This is cell cluster of different frequency band. This is the one cluster, this is the another cluster, and this is the another cluster, and this is the another cluster. Since each cell has its own frequency channels, and these are number of cells, so they will have their own frequency band. And if you watch it clearly, F1 written here and F1 written here, F1 written here, F1 written here. In the similar way, we can find out the other parameters, say F4 is here, F4 is here, F4 is here, and here. These are at a particular fixed distance, and this fixed distance is called reuse distance. The distance between the two cells using the same channel known as reuse distance and is represented by D. Where is the D? This D is under root 3 n into R. R is the perimeter of a equilateral triangle or the radius of a cell, and D is the distance between the two cells which are going to have the reuse distance, and n the number of cells in a cluster, and R we have already defined as a radius of the cell, or it is the one side of a triangle, equilateral triangle. Let us see how we see the reuse distance. Here in this figure, let us see, we have to find out the reuse distance between the two cells. See here, F2 is blinking, and in any two cells which have F2, this is called the reuse distance. Similarly, it is for 5 also. So, this is called the reuse distance, and in reuse distance the frequency will remain same. So far in this figure, we have taken only F1 or F5. You can choose any two numbers in any direction. The distance between the two cells which have the same number, it will be a reuse distance. For example, it is 7 is here and another 7 is here. So, this distance is also D. In the similar way, we can take some other word, anything. Say we take this F3, one F3 is here, another F3 is here. So, this is reuse distance. So, two cells which have a fixed distance have the equal frequency and equal channels, same number of channels of same frequency, they are called the reuse channels. And what is the reuse factor? The reuse factor is the ratio of distance d upon the radius r, that is d by r is equal to under root 3 n. See here, this is the same 7 cell cluster, but amongst the big cell structure. The same 7 cell cluster, but it is amongst the big cell structure. And this is one of the 7 cell cluster have taken from the big cell structure. So, that was the 7 cell cluster. This is the 3 cell cluster. So, cluster may have 7 cells, 3 cells, 4 cells, 9 cells, so many things, but there is a certain order. We will discuss about the geometry of the cells, we will decide how many cells are possible in a cluster. So, type of the frequency reuse factor, in some of the book it is written K, in some of the book it might be written as a Q also. So, do not confuse. K or Q is the frequency reuse factor, and that is d by r. So, where you use these things? K may have value 3, it is used in with frequency hopping. K is equal to 4 with or without frequency hopping. The student who have gone through the mobile communication, they understand the frequency hopping is used in CDMA system. So, K 3 and K 4 they are meant for CDMA system. The Reliance and Tata they use the CDMA system. K is equal to 7 with or without frequency hopping. K is equal to 3 with each cell sector. K is equal to 4 with each cell sector. So, these are for, if there is no hopping, means for GSM, the Airtel, BSNL, these use the GSM system. So, how will decide what should be the value of reuse factor, that is K. So, what will be the better value of K, whether it should be more or it should be less. The better value of K for reuse, it is better to have larger value of K. For larger value of K, there will be many cells in one reuse patterns. So, we will prefer the higher value of K. So, remember it, higher the value of K, you will get more number of cells. More number of cells means more subscriber. Grow network by cell splitting. If your subscribers are continuously increasing in the cell, then you have to find out some solution. Either reduce the size of cell, increase more cells. If you reduce in the same area more number of cells and you have to accommodate more subscriber, then split the cells. When business becomes good, we continue adding more cells inside the whole cells by reusing frequencies correctly. So, from bigger cells we will split into smaller cells to accommodate the higher density of subscriber. So, see here, this is one cell structure. In this cell structure, each cell has its own capacity. Say 6 to 8 channels are available for this purpose for a particular subscribers. In GSM system, you cannot go beyond the capacity of cell. In CDMA, you can accommodate more subscribers, but there is no way in GSM to accommodate more subscriber other than the prescribed channel capacity or cell capacity. So, you have to make a smaller cell amongst them. A cell is to be splitted from bigger cell to a smaller cell. So, we will do the cell splitting. The bigger cell can be split into a smaller cell. This is the large cell. From large cells, we have come to the small cells, and from small cells still we are coming to the smaller cell. So, we have splitted the 7 cell cluster into number of small cells to accommodate the large subscriber. The choice of hexagonal cells, while we are discussing about the cell design, we prefer the hexagonal cells. And what were the reasons? Additional area can be covered with additional cluster without having any overlap area. Therefore, hexagonal shape has been found suitable for the cellular communication. So, these were the reasons we prefer the hexagonal cell in cellular communication. And this is the same hexagonal cell cluster. These hexagonal cells, this is a cluster of 7 cells, 1, 2, 3, 4, 5, 6 and 7. So, this is one cluster, but only one, this is the hexagonal cell. And we have preferred this type of cell in cellular communication. So, this was regarding the frequency reuse and frequency planning.